Hello and welcome to the fifth installment of my How to Arduino series. In this video, we will be covering sensors and how to use them. If you've missed the first few videos in this series, there is a link to the playlist in the description as well as behind the little eye in the upper right-hand corner of your screen. With that said, here are the topics we will be covering in this video. We will be going over the photoresistor, what Arduino libraries are and how you can use them to have other people do your work for you, and how to set up a temperature and humidity sensor using one of those libraries. So let's get to it. First, we're going to build a light sensing circuit. That is going to be using the photo cell out of our kit, which looks like this. And we are going to hook it up in this fashion. As you can see from the schematic, this one's pretty simple. This is just a passive circuit, so we don't need to do any kind of powering for it or any fancy code or anything. This is just a resistor that changes value based on how much light is shined at it. So we hook it up to the positive rail, then we use a 220 ohm resistor to connect to the negative rail, causing there to be a voltage divider. In the middle of that, we hook up the A0 pin, and that completes our schematic. Once that's done, we can start making our code. As always, we're going to start with a constant integer that we're going to use to hold the pin number. We'll call it photo because it's a photo cell, and it's hooked up to A0, not AO, but A0. After that, I want to have something to hold on to the value that we're reading, so I don't have to keep calling analog read over and over again. So I'm going to make an integer called receive, and that's going to hold our value. The first thing in our setup is going to be a pin mode where we send it the photo pin and we tell it's an input. We don't need to turn on the pull-up resistor because there's no way that this will be left floating. After that, we're going to do a serial.begin at 9600 baud because we want to read the output in the serial monitor for this. Now that we start our actual code, we're going to take our receive variable and set it equal to the analog read of our photo pin. After that, I'm going to call serial.print, and we're going to say the value is another serial.print line, and we're going to give it the value to print out, which is receive. After that, we want to wait 1 second so that we have a chance to actually read what's going on. And that's it. That's all that's involved for this program. It's super simple. There's really nothing new here. So last thing that is left to do is to verify our code, make sure there's no typos, upload it to our Arduino, and open up the serial monitor to see what's going on. So we can see that it's sending a value of 861 each time. Apparently it's value because I can't type, but I'm gonna leave it because that's all right. So it's sitting at about 860. If I take a light and I shine it on the photo cell, then you see the value jumps up. And then conversely, if I take and put my finger on top of it to block the light out, it drops down to very low values. The next thing we'll do is going to be an active component, and we're going to read the humidity and temperature in the room. So here's the schematic for the temperature sensor circuit. The actual little board that you have in your kit is going to be a black board that has the blue device stuck to it, but there's still the three pieces that come out, so it's the same thing. All you need to do is hook the leftmost pin to A0, the middle pin to 5 volts, and then the rightmost pin to ground. So last video we learned about the Arduino API, which is sitting right here in front of us. It has all of the different things that are built in with Arduino that you can do. So if you want to make a tone, if you want to do delay, all of those things, there is something in C programming called a library, which is where you can import other code that someone wrote and then use the things that they have. All of these are technically libraries as well, but they're ones that are built into Arduino and you don't have to specifically call them. Now, let's go to the editor. Inside the editor, there's a couple things you need to do in order to use a library. First, you need to have the library installed on your computer. There's a lot of them that Arduino installs for you, but the one we're going to need today is not. So I'm going to show you how to do that first. Go up to Sketch, Include Library, Manage Libraries. That brings up this screen. Now the one we're going to need is for the DHT11 humidity temperature sensor. So that one is actually called DHT. If you want to find that out, you can do some web searches and stuff, but I'm just doing it all for you. And then right here, you see there's the DHT sensor library. That's the one we're going to need. So you click install. And now here it's telling us that there's a couple of libraries that library uses that we also need to have. We don't have them installed right now, so click install all and it will do it all for us. Now they are installed. If you go back up to Sketch, you can then go include library, and then you can find the one that you just put. This is in the recommended ones, DHT sensor library. And then it puts the include statements in the top for you. Now an include statement is just C telling it, okay, before we do anything else, look at these files. These files are as good as in this file. So it just takes it and it literally includes it into the file. That's why it's called that. Now you don't actually need to go into the menus and say include the library. You can just, if you want, type in the include statement like that. So you could just say include dht.h and that would do the exact same thing. But since it's already written at the top, we don't need to have it written down again. So now we have included our DHT library. That means we're set up to use the DHT library. In a future video, what I'll do is I'll walk you through how to find the information inside of the library that you're looking for in order to do things. I think what we'll do is I'll just do it, you can follow along and then kind of get an idea for how they work before I throw too much information at you. So the first thing we're going to need is we're going to need to have, as always, a constant integer that will hold our pin number. This time it's going to be the pin that the DHT, which is our temperature sensor, is going to. So we'll call it the DHT pin, and it is pin A0. The next thing we're going to need to do is we need to talk to the sensor. So in order to do that, we need to have a way to reference that specific sensor. So we will make a variable to hold on to it. Well, what kind of variable is a sensor? Like we know integers, we know floats, we know all these things, but there's no, we can't just go like sensor, right? There's no such thing as that. So what is it? The answer to that actually belongs to this right here, our dht.h. Inside of that library, they create a variable that holds on to a DHT sensor. And in this case, they happen to call it DHT. So we make a variable of type DHT. We will call it DHT because it is a DHT sensor. And in order to make one of these, we need to give it some information. There's 2 bits of information that it needs. It needs the pin that it's hooked to, which we call DHT pin, or A0. And then it needs to know what type of DHT sensor it is, because there's 3 different types that this library works for. The type that we have, according to the inside of the lid of our kit, is a DHT11. So we give it the pin number and the type. Next, we need to do our setup. Now, normally what we need to do is go pin mode A0 equal, or A0 output, right? However, this is a little different because we have a function called dht.begin. What this does is it initializes our sensor, including assigning pin numbers and such, because we've already told it what the pin number is. So it uses that pin number, it sets it all up for us and does it. Now for this program, what I think we'll do is we'll have it print to the serial monitor so that we can see what's going on. So that means we'll also need to do serial.begin. We'll do 9600 baud. So that is our setup. Inside of the loop, we're going to need to gather the data. So for that, we'll use floats. If you don't remember, a float is a floating point number, which is just a decimal number. We'll have H because we'll gather humidity, and that's going to be DHT dot read humidity. We'll need another one. It's going to be for the temperature. So we'll do read temperature. We'll do one more, and we're going to call this one F, and it's going to be read temperature, but this time we're going to pass it true. So inside this DHT library, there are functions defined, like we wrote the change color function before that has their own. That's what all of these are. Everything's just functions. Whenever you have parentheses like this, you're calling a function. So they defined one called read temperature. Now for read temperature, you can either give it true or false. If you put nothing, it defaults to false. And what that is it is asking whether or not you want to convert the temperature to Fahrenheit. So our T value should be in Celsius and our F value should be in Fahrenheit. Now we need to set up some print statements in order to show us our data. So we do serial.print. And we're going to need this a lot, so I'm going to copy it just to save some time. And we'll say the humidity is, and then we're going to call H. And then I want to do a print line on this one. So I want to end the line after I say what the humidity is. So I'm going to print line and I'm going to say %, just so it's very clear what we're showing. So I put 3 print statements up. If you remember, print by itself does not end the line. So this will say humidity is, then it will put our H, which is our humidity value. And then we say print line, which will end the line when it's finished, and put a %. So it's going to say humidity is blank %. So we're going to do that. We'll just continue with the same thing for I'm going to copy and paste this to make life a little bit easier. So now we have that value, which is going to be for our Celsius. So temperature is, it's not H, it's T, and that's not %, it's Celsius. And instead of a print line here, no, I do want print line. So I'll put another here, that print, or, and we're going to call the Fahrenheit one, and then a print line for the last one. So we'll say in degrees Fahrenheit if you prefer. Now we don't have to type all this, but it makes it a little bit neater. And in the case of making it neater, what it's going to do is going to print 3 lines of text. So it's going to print a line of text, another line of text, and another line of text. And that's one loop. Then immediately it's going to print another line of text, another line of text, and another line of text. There's 2 problems here. First of all, it's going to be doing that at 16 kilohertz. I don't want it going nearly that fast. I can't read that fast. So I'm going to need to put a delay in. So we'll do that first. Delay, and we'll wait 3 seconds. Okay? The other thing is, it's hard to tell where one group of readings ends and the next begins. So what I'm going to do there is I'm just going to put this serial.print line, and I'm going to leave it empty. So what that will do is it'll just make an entirely empty line. So this one ends a line, and this one ends a line. So it's just going to have 2 spaces, just like this does right here. And then I'm going to have to delete my little example here because that's not code and that will confuse the compiler. So I will save this. I'll call it a temp test, which I've already named it that once before. Yes, I want to replace it. Then we'll upload. Click here to bring up our serial monitor. And we start getting different values. So now we can see where I made a mistake. It just says or F in degrees if you prefer. Why is it doing that? Let's figure it out. Well, right here, I put quotes around my F. So I'm telling it the string F instead of the value F. So take those quotes out, try again. I'm sure everyone caught that and was screaming at me for that it was wrong, but that's okay. Bring back up our serial monitor, and there we go. So in the room I'm sitting in, we're at 32% humidity, 21.3 Celsius, and 70.34 degrees Fahrenheit. Not bad. With this, we now know how to gather real-world data from a sensor, which we can then use in our code for something. For instance, instead of printing all this data out, we could just use these values. So let's just take a quick example. We'll say if the temperature, we'll use the Fahrenheit temperature because I'm in America and I understand Fahrenheit better. We'll say if it's greater than 70 degrees, so 70.0 we'll say, we will do another print line. The temperature is warm. Then we'll do an else. So we do another print line. We'll say that's cool. So now if we're above 70 degrees Fahrenheit, it will print this. If it's below 70 degrees Fahrenheit, it will print this. So let's try it out. We should know what it does because we just saw what the temp is in here. So we'll upload it. There's not 2 R's in print. It's only 1. We'll upload it. Bring up our serial monitor. And there we go. Humidity is 32, temps 23, 70.34. The temperature is warm. Now you see, I didn't do the little extra print line trick I did before, so it's coming up with no space in between those. That's no big deal. You could easily add the extra print line and make it cleaner if you really wanted to. What other ways could we use this? I think a good example of this device is a terrarium, because we're also gathering humidity information. So if you had a terrarium, you could have this sensor inside of it hooked to the Arduino, and then hook it up to the humidifier and the heater. So if the temperature drops below a certain value, or if the humidity gets too low, it can then fix it and keep your animal happy, which is kind of a cool little deal. Now that you have a little bit of experience working with Arduino libraries, we're going to mix it up a little bit. I'm going to give you the link to the API for a library, and I want you to use that as well as what we've learned this week to make the ultrasonic range sensor sense something. So what I would like is for you to go on your own, install the library as we did using the library manager before, then use the information on the API. It's an extremely well-written API that actually kind of has a little tutorial to walk you through it. So here's what that API looks like. You can see here it's a GitHub page. You scroll down and you see everything that's going on. It has a wiring diagram that you're going to follow. It has a little tutorial to follow on how to do what you're supposed to do. It tells you how to import the code. It does most of it for you, but I want you to go through and figure out how to do it. And when you're done, I would like you to build a little circuit that will use the ultrasonic rangefinder to measure out the distance to something in front of it in both inches and centimeters, and to display that in the serial monitor. With that, we are done for this video. I'd like to thank you for watching, and I hope to see you next time.